Okay, we were talking about inverse functions, and where we left off, you had figured out that yeah, negative y equals 3x plus 6, and you did all the work to get right there, and you did that perfectly. Um, but as you pointed out, then you don't want negative y by itself; you want y by itself. Well, you got to be clear on then to change negative y to positive y, you've either got to multiply by -1 or divide by -1. And when you do that, your multiplication and your division go to both terms. So the the 3x becomes negative 3x, and the 6 becomes negative 6. It's like a distribution. It's like it's easier to think of as distribution when you're multiplying by -1 because you would distribute that. But when you divide, you're really just multiplying by the reciprocal. The reciprocal of -1 is -1. In any case, this is what you want as the inverse. I believe what you started with was, let me work backwards and see what you started with. I'm going to pause this. Okay, and I apologize for the handwriting, but it looks like you started with y equals -x minus 6 over 3. So these should be inverses, and if I wanted to prove it, I could do this. I could go -3 parentheses negative x minus 6 over 3, close parentheses, minus 6. I feel like we did this together also. Distribute, and you get positive 3x plus 18 over 3. And I guess there's other ways to have done what I just did right there. Minus 6. And that's going to simplify to x plus 6 minus 6, or x. So yeah, these are inverses. Okay, let's see what happens when we graph them. But to graph them, here's what you need to realize. And I guess there's a lot of different places we could go to show how this works. A lot of different sites I could look at. The one I was looking at earlier today was this one. If we go to algebra, we can look at, this is graphing lines. So whenever it's just one like a linear equation, you were saying we could always plot points to graph lines, right? That's easy enough. However, really what you want to be doing is using intercepts. You can start graphing with the intercept, especially with the y-intercept. And if we can get it in slope-intercept form, that's the best way to graph. This video is all over the place, I realize that. But the best way to look at it is right here. Y equals mx plus b. Or we can do a couple. Y equals x plus 3 is what we were looking at before. Starts on 3, goes up 1 over 1, up 1 over 1. And if it's 2x plus 3, the slope changes. If it's 3x plus 3, 4x plus 3. Cool thing about this program, if you want to just try a bunch of different things for the slope, you can put a variable in there and click Add Slider. So there it is with y equals 1x plus 3, but you can see by moving the slider, as the slope gets bigger, the line gets steeper. It goes all the way up to 10. It could go higher in theory, but this application only goes to 10. And if it gets lower, there it is at 1. Then between 1 and 0, these are fraction slopes. It's 1/2 right there, up 1 over 2, up 1 over 2. And it's getting closer to 1/3, 1/5, up 1 over 5, up 1 over 5. There's a up 1 over 10, and then at 0, it's totally flat. That's just y equals 3 if you think about it. Y equals 0x plus 3, and there's no slope whatsoever. And then we get negative slope, and it starts to go downhill. So you just think down 1 to the right. In this case, down 1 over 1, down 1 over 1, down 1 over 1. Now, a lot of people have trouble figuring out, well, why is this positive? Like, why is positive to the right and negative to the left? One way of thinking about that is if you go back over here, if I look at there's the y-axis, there's the x-axis. And if you think about it, this is, if you, in the x-axis, I'll make that yellow, and the y-axis will make this orange. And where's the positive for orange? Well, it's up here. Where's the positive for yellow? Well, it's over here. It's for x. And the negative for x is over here. And the negative for y is down here. Whoop. Well, this makes for a negative slope going in these directions, both these directions, because this, like, only a negative slope could change positive x to negative y and negative x to positive y. It takes a negative to change a sign. This is positive slope because it goes from negative, I mean, it keeps a negative as a negative and it keeps the positive with a positive. So that's one way to think of slope, which ones are positive and which ones are negative. So back to this deal, you know, steep negative slopes, they still have that orientation, but they're just steeper. So this is just how you, so this is partly explaining you how to graph, but the starting point of your graph is the y-intercept, and that's this thing that gets added to. And the way you can think of it is, if you plug in 0 for x, then you'll be on this line. This is the line, the y-axis is the line where x equals 0. So if you just cover up mx, you'll get what's left over right here, and this is, so the y-intercept will always be right here. So, and to show you what that looks like, I'm going to do what I did with the slope. I'm going to plug in a variable. I'm going to plug in b and add a slider. So now there it is when it's 1, but if I move b up goes the line. So now b is 6, and b is 7. Now if I move b down, there's b is 0, and now it passes through the origin. B is -2, b is -8, -7, and so on. All right, so what's our point? Why do we even start doing this? Because I think we wanted to graph this. So y equals -3x minus 6, so if you didn't have this calculator to graph it, you would just say, okay, y equals 3x minus 6. That means I'm going to start at -6, and that's going to be my point right there. So I'll plot the point 0, -6. And then my slope is -3. So if it's a negative slope, I'm going to be going down that way. Or if I go up, I'll be going to the left. So it's this kind of line. So going back over here, that means I would go down 3 and over 1, but that's going to take me off the map. So I could also go up 3 over 1 and plot a line right there. And do that again, up 3 over 1 that way. And I got this line. And I could keep doing that. I'm just adding, going to the left 1 and up 3 every time. So the next line, the next place will be -5, and then I'm adding 3 to the y coordinate. So 6 plus 3 is 9. Now, and then I can draw my line based on that. Now, what does that look like? Y equals -3x minus 6. So you don't have to. So after a while, well, I was going to say you don't have to plot the points. You can just plug it in, but no, you do have to plot the points. The way we plotted the points is the way you will be plotting the points when you graph these equations. All right, what does this have to do with inverse functions? Well, let's look. The original g of x that you were given was -x minus 6 over 3. So that was what started this whole charade. How are we going to graph that? Y equals negative x minus 6 over 3. Well, again, remember what happens when we divide? The division goes to everything. So really, what's the slope here? Ask yourself, what's the slope? Pause the video. Ask yourself, what's the slope? If you think about the 3 going with that negative x, it's going to be negative 1x, so negative 1 over 3x. Now, what's the y-intercept? What's the y-intercept? Now, and maybe if you have no idea what I'm talking about, then what you need to know is that the slope is always the number in front of the x, and the y-intercept is always the number being added or subtracted if it's negative. So in this case, the y-intercept is negative 2. So that's how we're going to graph the original function. We graph the inverse, negative 3x minus 6. The original function is negative 1/3 x minus 2, right? So we'll plot, here, let's get rid of all these points. We'll plot 0, negative 2. And then we're going to go down 1 over 3. So we'll get negative 3, negative 3. Whoops. Go positive 3, negative 3. Down 1 over, we'll go over 3, down 1. And, and that's going to give us a straight line. Now we can graph it. Y equals negative 1/3 x minus 2. Okay. Now for the whole point, what this has to do with inverse functions. Every time you graph inverse functions, they make a reflection across this line. Y. This is the line y equals x. Inverse functions are where x and y are switched. So there should be they should make a mirror. So if you have that, this is your mirror, since x and y are switched. So like here I've got the point 3, negative 3. I should be able to switch those over here in the mirror, and now it's negative 3 and 3. Here I've got the point 6 and negative 4. Well, over here I should have negative 4 and 6. Yep, there it is. So here I've got the point, looks like 3 and negative 15. So if I go over here, I should find negative 15 and 3. So inverse functions will always have this property that they make a reflection. That doesn't mean you can tell which one's the original and which one's the inverse, but they're inverse of each other, so they reflect across this. And I'll show you a couple more just to prove it to you. Here's y equals x, that's the mirror line. Here's y equals x plus 3. Here's its inverse, y equals x minus 3. The inverse of multiplication is division. Multiplication, y equals 3x. Division, y equals 1/3 x. See that, you can see again, if I get rid of the first one, there's that reflection. And the last problem, I think, or the next problem you're going to have, there's y equals x squared. What's the inverse of squaring? Taking the square root, of x. But the trick is, this is a positive square root symbol, so this part of the reflection is missing, because that's the negative square root. All right, I hope that helped. You can watch more videos on my YouTube channel. No, actually you can't. This is pretty much the only one.